Hey guys, welcome back. Well, a funny thing happened on the way to the garbage bin with all of my out of focus images I've been taking lately with my SCT. I actually found an object traversing the image of M82, and I wanted to show it to you and see if you could help me figure out what it is. Created a stack of all the images that I recorded. This is like over about a 9-hour period on January 28th, 29th, and I ended up with this streak going across the base of M82 here. And it's odd in first place because, as you know, with satellite trails we see a streak that goes across the entire image, but only one image because the darn thing is moving so fast. Here, this is a period of 9 hours, and I'm getting a very short, finite length streak just in this area here, and I'm actually just a little surprised that the pixel rejection algorithm in PixInsight didn't just delete it. So anyway, I went back and investigated to see what this is, and I found when I looked at individual images there was a point of light that was bouncing back and forth along this line. And the reason it was bouncing back and forth is I put the half-flux radius in the file name, so when the files are loaded into Blink, for example, they're loaded in not in chronological order but in half-flux radius order, and that creates a random motion of the point here. But after going back and reconstructing the files with just the time and date code, I was able to look at this point and how it moved over time. And let's go over to PixInsight and the Blink utility, and I'll show you what this looked like. Got the images loaded here into Blink. The file names are truncated, so this 28 is the 28th of January, and the first image is taken at 9:35 that night, so 21:35 local time here, and they just proceeds on until about 6:30 in the morning when I shut down the imaging session. And what we're going to be looking at, you can obviously see M82 here. The point that we're interested in is this guy right here, and now we'll just run this and you can see it moving across the sky. Now it'll go, of course, out of focus and then snap back into focus. It's out of focus now, and it snaps back into focus and it goes out of focus, but it moved. But you can see the speed at which it's moving, which is to say very slowly as it's going across this image here. So this is a period of about 9 hours as it moves from where it started to where it ended. I created a composite image from the first image I took that evening to the last image I took the next morning, and that spanned a range of observations from, in this case, the UTC time is 3:35 till 12:28 on January 29th. And the object started here, so it's starting at a declination of 69.42 and just a little bit short of a right ascension, 9 hours and 57 minutes. And over a period of about 9 hours, it moves from here up to here, which when you do some calculations, you can find that's a distance of 568 pixels that it moved at a image scale of 0.343 arc seconds per pixel. Now the question that occurs to me is, could this object actually be orbiting the Earth? So let's do some simple math and find out if that makes any sense at all. If we're going to orbit the Earth, we've got some object out here at some distance from the Earth, and we'll go ahead and assume that the orbit that we're talking about is circular. And if we take the angular velocity that I calculated based on the image there, that's 195 arc seconds and almost 9 hours. And so that's the omega that plugs into here, and then there's some radius, some orbital distance out, and that r times omega gives us the orbital velocity or tangential velocity along this path. But in order for an object to stay in orbit around another object, there has to be some acceleration vector that is bending this velocity vector into the circle. And as long as we're not talking about a starship here, we're talking about a body with no propulsive capability on its own, that acceleration has to result from the attractive force from gravity between the Earth and the object. And so what we're looking for is the value of r, the distance from the Earth, where the centripetal acceleration is equal to the gravitational acceleration, and that's r omega squared is equal to Newton's gravitational constant times the mass of the Earth divided by whatever this radius is squared. And whenever this is true, then it is possible to have an orbital condition, and we can plot that up here. For example, on the orange curve here is the centripetal acceleration. Gravitational acceleration drops off fairly rapidly, with distance out because it's divided by r squared. And where the two lines cross is where the centripetal acceleration is equal to the gravitational acceleration, and that occurs at a distance from the Earth of 7.7 million kilometers. Now, just as a matter of scale, this is where the moon is. All right, so we're talking about something that's quite a bit farther away than the moon. The JWST just reached its Lagrange 2 equilibrium point, and that's 1.5 million kilometers from the Earth. So we're talking about something that's very far away. And if you remember the distance that Mars was from the Earth at opposition recently, that's about 55 million kilometers away. So we're about 1/5 of the way to the closest point between Earth and Mars. So it is possible that this object could be in orbit around the Earth, but it's very unlikely. There are some web-based resources out there where if you know a comet's designation or an asteroid or a space probe, you can type it into, in this case, the Sky Live, and you can enter your location on Earth, the time of the observation, and it will show you where that particular comet, asteroid, or probe is. I want to do the opposite thing. I want to take a known observation time and location and RA and deck coordinates and have it tell me what the asteroid or comet or space probe is. Now, it may be that there's a way to use this resource to do that. I just don't know how to do it. But I did find one example of a comet that was at least in the general neighborhood at the time of my observation here. I've got the clock set down here to the 28th of January at roughly 10 o'clock. This particular comet was in the general vicinity, but in order for it to be the object that I was taking a picture of, it would have to be inside this circle here where M82 is, and that's a pretty far distance away. So this isn't it. What I would like for this resource to do is for me to be able to type in a time and point to an area of the sky and have it go through all of its database to find those objects that satisfy these conditions. That way I could pick out what this object is. I just don't know how to use this resource, or if it's possible to use this resource to do that. Looking on the bright side, I suppose in every pile of garbage there's potentially something of value. In this case, I managed to observe a comet or an asteroid, probably, on January 29th near M82. While most of my images are not useful in terms of making a nice picture of M82, I'm at least able to observe this slow-moving object. The observation lasted 8.9 hours, and the object only moved 195 arc seconds, so it didn't go very fast. It's clearly not one of the typical satellite trails that we see in our images. This one took forever to get across just a little piece of the image over a 9-hour period. If it's orbiting Earth, and it probably isn't, it's 7.7 million kilometers away, which is it's pretty long. JWST is only 1.5 million kilometers away, and Mars gets as close as 55 million kilometers away. But I seriously doubt this object is orbiting the Earth. Online resources, one of them that I looked at, the Sky Live, it lets you identify a known comet, asteroid, or space probe and show where it is in the sky at any particular time. But that's really not what I'm trying to do here. I'm trying to go the other way. I'm trying to take a particular position in the sky and time and have it tell me what was there at those coordinates. Unfortunately, I don't know how to use this resource or what other resources might be out there, though I have done a little bit of a search. So if any of you guys know a resource out there that would let me nail down exactly what this object was, I'd appreciate it. Just drop me a comment and I'll look it up and put that in the description. Okay, guys, well, that's all I have for today. I'll talk to you later. Clear skies. See ya.